What was just discussed was the difference between accuracy and precision. As we look at this trials done by 3 different students for determining the weight of a lead block, which has a true value of 10 grams, we were able to identify which student had accuracy and precision just by viewing here how consistent their data was and how close it is to the true value. We have determined that student C is both accurate and precise. Student B is precise but not accurate. And student A is neither accurate nor precise because each one of these values vary from each other and they are a bit far from the true value of 10 grams. Now, in order to calculate precision, you are learning that you can determine the percent precision. The lower the percent precision, the greater the precision. So I am going to go through with you how to complete the percent precision for student A, and then you will complete student B and C in the coming activity. So student A, we've already said, is neither accurate nor precise in comparison to student B and C. Let's see what that precision percentage is. So on the board here, you will see that I have written out what the trials were for student A. So the student has varying results here. And then we are also given the average of the 4 trials. Okay, so in order to determine the percent precision, what we need is to determine average deviation and then divide that average deviation by the given average and multiply it by 100 to make a percentage. So to begin with determining the average deviation, we first need to find out the deviation of each trial from the average. Deviation from the average is going to be a subtraction. How far away does your measurement deviate from the average? That's going to be the deviation from the average. So what we're going to do is take a subtraction from taking the average minus your measurement and take the absolute value. By taking the absolute value, this gives you a positive value for your deviation. So for trial number 1, we're going to take our 10.13 grams and subtract 10.49 grams to give us the deviation from the average to be 0.36 grams. Now we're going to be following significant figure rules as I'm going through here. As you progress through the rest of this presentation and this lesson, you'll start to see what I mean by significant figure rules. But as you watch me complete these calculations, you'll notice that I am following those significant figure rules. Next, we have trial 2, which is going to be the absolute value of 10.13 grams minus 9.79 grams to give us 0.34 grams. Now for trial 3, the deviation will be 10.13 grams minus 9.92 grams to give us 0.21 grams. And then the final trial, trial 4, we'll be taking the absolute value of 10.13 grams minus 10.31 grams to give us 0.18 grams. So once you have each of the deviations for the 4 trials, we're going to average those 4 trials together. In order to take an average, we add together each trial and divide by the number of measurements. So in this case, it is 4 trials. So we're going to add each one of these and divide by 4. So I will write this all out here. We will begin with 0.36 grams plus 0.34 grams plus 0.21 grams plus 0.18 grams. And we're going to divide this by 4 since there are 4 measurements. What we're going to do is now add together the 4 measurements. So if you have your calculator, you can be doing this along with me. And what you should get for the top here, your numerator would be 1.09 grams divided by 4. And then your final answer here, when we divide by 4, I'm going to be rounding it to 3 digits because our number here has 3 digits. And this 4 is an exact number because it was determined by counting. You will see this as you progress further into the significant figure rules. 0.273 grams. So what is this value that I just determined? This is the average deviation. So this is equal to your average deviation. So I need to make some space for myself here for a moment. So I'm going to erase this portion here where we determine the deviations. But remember, the calculation involved taking the average minus the measurement and taking the absolute value. The absolute value always makes the number positive. So now we're going to reach the final step, which is applying this formula. Percent precision is equal to your average deviation divided by the average times 100. So now we just determined the average deviation is 0.273 grams. So I'm going to switch up my colors here. Let's see how this one works for me. And we're going to determine that the percent, this isn't going to work so well. Can't see that too well. Let's try. No, that's not so visible either. Everything's about trial and error. I'll just stick with the black marker. Okay, so percent precision will be equal to the 0.273 grams. Remember our units, every number must have a unit, divided by the average, which is 10.13 grams times 100. When we do this math, you put this in your calculator by taking the 0.273 divided by 10.13 times that by 100. What you should get in your calculator, you will round 2.69%. Okay. And now that's for calculating the percent precision of student A. So we look at this and we say, well, that's not very small of a precision, or that's not too big of a precision. So you think, oh, the precision's pretty good. It's only 2%. Well, the smaller the precision, when you have precision percentages that are a decimal, that makes your measurements even more precise, okay? So what we noticed here was that we saw that each one of these trials varied in their measurement. So when this occurs, this means that there is some kind of random error that is occurring, or it is a systematic error that is occurring, that there's something wrong with the scale that you're using and it needs to be properly calibrated.